Hi everyone, welcome back to Data Testing Zone. Till now we have seen altogether 7 test cases, executed them successfully, and all test cases are passing as well. Now, this is gonna be our last video for this project. We will be discussing our last test case, which is percentage of orders dropped or increased per year. Okay. When we see the data set, right, we have order date column. So from here, we will be extracting the year, okay, and we will be calculating the total number of order IDs per year, and we will be seeing the change via the CSV file. Okay, and the same thing we will be comparing with our Postgres data. That is the data that we loaded through that file. So our source is always CSV file from where our data was loaded into Postgres, and our target is ultimately Postgres only, right? So when we run this query, we are getting that for each of the year, if you see, the total orders are increasing. So as such, there is no decrease in total orders per growing year, right? So there should be the same pattern that we should be getting through CSV. Okay. Now let's get this verified via test case in our framework. Okay. So for this, like I mentioned, we will be writing a custom logic to do this. Okay. So the custom logic will be sitting in this util spy. Okay. Why? Because the custom logic has like the number of lines of code that this logic holds is a bit larger. So it is not a good practice to put a larger number of code in this test validation file. Okay. It should be limited to what we really need to pass on the logic at the runtime. But again, since this is some conversion and all that transformation also, so we can use it in utils, and you can use it for other projects as well. You can just import this particular file, and then you can use it there as well. Cool. So let us get started. Let us write a method to calculate yearly drop status. Okay. Yearly order drop, not drop, yearly order drop status. Okay. And then we'll be giving we will be comparing the Superstore CSV against our DB, right? Against our DB Postgres data. So let me just give 2 arguments for this. Okay. And then let us give some stock strings. So this is to better you just for explanation only. So let us give that first. We will be doing some CSV calculation. Okay, we will be taking the order date from CSV and doing some transformation over there. So let us keep it here as CSV calculation. Okay. Now next is let us read that data. So this data is Superstore CSV, and then the column is order date. Okay. And then we will always convert the type into string so that we will be able to split it without any error. Okay. So for split, we will be using regex, because if you have seen the data set, somewhere the dates are with the hyphen, somewhere it has backward slash. So it is not a unified format, right? But one thing is in common, which is the year is always at the end. Okay. So what we will do is we'll put regex over here and then do our split operation. So regex is some nothing but we'll do on these two. Okay. And then we will get string -1 as type and then int. Okay. Why? Because we are just rotating it again to int. We are not keeping it as year. Okay. Because we need to do some calculations as well. So this is the best practice for now. Now, this is our, now let us store this inside a variable called as Superstore CSV, and then let us create a column as year. Okay. So we will call this as this. Okay, there is a spelling mistake. Okay, so we are storing the data that we are getting from here inside this particular column. Okay, we are just initializing a column, name it as year, and then we are putting the value over here. Okay, now next, let us do CSV orders. Now this is to calculate orders on the basis of year. Okay, again, we will just do Superstore CSV dot group by, Similar thing that we did on last tutorials as well. We will just do year. Okay. So we have this column right now. We have created it, right? Now this column we will be using it to group by to year. Earlier, this column is not there in Superstore CSV already. We have created it here and we will be using it. Okay. And then we will do it as order ID. Okay. And then we will do count. Then we will reset index. Like I mentioned, this normally a group by has a tendency of resetting the index. So we will just set the index on total orders now. Okay. I mean, we will say that the index will be total orders. Okay. Now this is our CSV orders. Cool. Now we will just do percent. We'll calculate the percentage change. Now how we are gonna do it is CSV orders will create another column named as percentage changed. Okay, this is fine. And then we will do CSV orders. On what basis we are calculating the percentage change? On the basis of total orders, right? Total orders is the index that we created on top, right? So we will be doing this on this one. And then we will be calculating PCT change. Okay, it is a function from Pandas only, which provides the change in their time kind of series. Like in incremental format, it will tell you like what is the percentage change between the former and the between the predecessor and the successor. Okay, so that is what it will tell you. So we will be using this right now, and then fill NA, then 0. So anything that has, so the very first year, right, it will not have any kind of percentage change. So we will just give it as 0, okay? And then we will round it up to 4. Yeah, 4 would be good, okay? Then we have already done percentage change. This is good. And then we will do CSV status. We'll store it here is equal to, we'll create a zip, this, and then CSV. Okay. Then it will give it on year. Okay. And then CSV orders. Okay. And then PCT change. This particular column. Okay. Okay. So we should be good. The dictionary of this CSV orders and then years, and then CSV orders and then percentage change. Okay. So this is how we calculated CSV. Okay, what we did is first we extracted the year, then we calculated the total number of orders, and then we calculated the percentage change. And then we are creating a CSV stats variable, which is storing a dictionary in the form of year and total percentage change in the orders. Okay. Now next is let us do Postgres calculation. Okay. So in this Postgres calculation, let us first keep this as DBDF so that it should be easy for us to read data frame. Okay. And then we will pass here as DB result. Now from where we'll get this DB result, I'll tell you. So obviously we have put it here as variable also. So we will not pass this. I mean, we will not use this method directly to call. I mean, we will be doing it in a test validation file only. So it will be called from there. So I'll tell you how we can do that. Now period data frame, and then we will be passing columns. Okay. Columns is equal to, what are the columns we are using? We are using year and then total orders. Okay. Now this is the data frame that we are creating. Okay. Now what we are doing is we are DB df calculating PCT change. Okay. Now PCT change is nothing but DB underscore df total orders dot PCT change. Again, this function will be calling over here, this method. Then fill any. For similar reason, we don't want to add first entry to be empty. So first year to be empty. So we will be rounding it up so that our both of the results set be unified. Okay. And then again, we will be storing this into DB stats. Let me just keep it as it is. Okay. We will just, instead of CV orders, we'll be changing it to DBDF. Okay. Good. Now, then we will just keep it as DB stats. Okay. Now we will just print both of this, okay, so that we can see also what is actually happening. Okay, let me put this string. CSV status is okay. CSV status is, and then we will be putting it as here CSV status. Okay. Then same way we will be printing DB status. Okay. And then DB. No, this shouldn't be your. Okay. Good. Now till here we should be good, and then we will compare finally. Okay. So I'm just writing a comment over here, and then if DB stats is equal to CSV stats, then print year over year growth stats match CSV versus DB. Okay. And then else we can put it as print mismatch found. Okay. And then we will again print the same. I don't think we'll print it, just we will return false, okay? Then here we will return true. Why I'm not printing it? Because we have already printed it here. So even we will be able to see if it is matching or not. Okay. So I think that's it. This is the entire function. We are not doing much here. We are just taking the year and calculating, and we are using this particular method of Pandas to identify the percentage change. Okay. Now we will go into our test data validations file, and we will just write down another elif statement in this one. Okay. Because if you see the test case for this particular, test case, query and logic for this particular test case, it is starting with select, right? And like I mentioned in my earlier videos, whenever a query or logic is starting with select, it will go inside this, okay? And then we can put an elif statement to identify which particular test case is here. So let me write another elif statement that will tell this is going into this particular, test case. So, okay, elif query logic. Let me see what is the option here. Test case name, right? So let us use test case name. Not this. Test case. And then let us use this particular column. Just a second. Okay. Test case name. Okay. Dot starts with. Then we will just put, what is it starting with? It is starting with percentage of orders, right? So we will put percentage of orders over here. And then we will just run yearly order drop. That's the function. Let me take it directly. Okay. And then we will pass superstore CSV, comma, our result. Okay. Then we need to import it, I think. Yeah. Okay. This is imported. Now let us go ahead and run this in our terminal. Okay, so let me just clear the screen and close the test case file so that we don't have any kind of issue. I don't want to save it and the test case file as well. Okay, now let us see if it runs pytest-vs and okay, we will be creating reports. Post that pytest test data validations. Let us see if it runs successfully. So it's taking a lot of time. Collected 8 items. Nice. Okay, it is saying that this attribute series object has no attribute as split. Okay, what is the problem here? So order date has type and then split. Okay, this is strange. Let us go back to our utils and see where it is coming. This is coming from here, right? Where we are using split. Okay, so in split, what is the issue? We are doing it as order date, right? This is good. Order date is good. Then we are doing it as type and then string also. Okay, we need to convert it again to in string. Okay, and then basically we will be splitting it out. Okay, I think this will be fixing the problem, but let us just cross check by running the test cases. Okay, column order ID not found. Okay, there is a key error. So where we are getting key error, we are getting this key error in CSV orders, right? And where it is in line number 15. Okay, so line number 15, it is year and order ID. And this is grouped on this. I think, let me open it. I think the data is ID is capital, but let me just confirm. Just a second. Yeah, it is capital. Okay. I hope this will solve the problem. Okay. Okay. Okay, it has again failed. So now the column year. Okay. From where it is coming? Which DB stats. Okay. Now DB stats we have used here and in DB, okay, it is not in capital letters, it is in small letters, right? DB we have unified the data there. Okay. I hope this will be our last run and I hope it runs successfully. Let us see. Perfect. Yeah, so it ran and we have all the test cases passed, total 8 test cases, and it all has passed successfully. So if you see, CV stats is this, okay, and DB stats is also this, right? Now, as I promised, we will be creating a report also on top of this one, a web page report. So it is a very simple thing to do this. So let us just put PyTest, okay, and then we will be just doing adopt is equal to -v -html is equal to reports and then report.html. So it will create a report folder, okay, and then it will create a report.html file inside that, and it will be self-contained HTML, okay. That means self-managed HTML, okay. Now this is the code that we need to write. I hope this will run and we will be getting our reports as well. So let us run it and see if it creates a report or not. Perfect. It has created a report over here. So if you will go inside this, okay, and you will be given an option to open it with any of the browsers. So I will be opening it with Chrome, and if you see, We had 8 test cases. These were the 8 test cases that we executed. This was the duration, and all these 8 test cases have passed. This is a very basic level HTML test report that Pytest has generated on its own. Okay, so it can generate good reports, and with much more functionalities, we can even do that. Basically, I'll take it up in another framework kind of session, but for this framework, for this project, that's all I have. I hope you have learned a lot of things from this video. If you need assistance on any other kind of, even PyTest or Pandas as a whole session, please let me know. I'll find out some time and try to record for that as well. Okay. So yes, please do like and subscribe. Thank you so much for following along.